During the monsoon season, the Brahmaputra expands so much that in parts of Assam and Bangladesh, the opposite bank disappears from view. It aggressively swallows entire landscapes under millions of gallons of muddy, violent water. But a waterway this massive and chaotic doesn't materialize out of nowhere. To find its starting point, we have to look thousands of miles from these flooded plains, up into the silent, sub-zero peaks of southwestern Tibet. At an extreme altitude of 5,150 meters sits the Chemayungdung Glacier. This frozen, desolate environment is where the river begins. Here, it is a tiny, peaceful stream of melting ice, a far cry from its later form. The locals call it the Yarlung Tsangpo, or the Holy Purifier. The question is, by what geographic and climatic mechanisms does this freezing stream transform into a devastating monster? The river's initial 1,700-kilometer journey takes it eastward across the cold, wind-swept Tibetan plateau. Between November and February, the river enters its winter mood. Because the environment is too cold and dry for rainfall, the waterway starves, fracturing into thin, shallow streams. In this arid region with no winter rain, these glacial streams provide the primary source of water for the small settlements scattered along the valley. Eventually, the water's eastward path hits a massive roadblock, the sharp, imposing peak of the Namcha Barwa mountain. With its path blocked, the river makes a sudden, dramatic U-turn, carving a path directly through the Himalayan mountain range. It carves out the Yarlung Tsangpo Grand Canyon, one of the deepest on Earth, and plummets toward India's Arunachal Pradesh. Gravity and the extreme drop in elevation weaponize the water, accelerating it from a slow stream into a high-speed torrent. The water surges into the Assam Valley and merges with the Dibang and Lowit tributaries. Only now does it earn the name Brahmaputra. During the pre-monsoon season, rising temperatures cause the Tibetan glaciers to melt rapidly. This sends a massive surge of water rushing down the mountain canyon. As this glacial surge arrives, the river enters a subtropical zone located near some of the wettest places on Earth, such as Cherrapunji. The monsoon climax between June and October creates a violent collision. This diagram shows massive glacial melt entering from the left, impacting explosive monsoon rainfall over the plains. The river takes on its Raudra Roop, its furious form. It breaches its banks and expands miles wide, triggering catastrophic floods. This destructive power is the result of two opposite climate systems crashing into each other simultaneously. The swollen river crosses the border into Bangladesh, where it adopts a new identity as the Jamuna. In this flat terrain, the waterway becomes so wide and heavily braided that crossing it requires massive infrastructure. Finally, it merges with the Ganga to create the Sundarbans, the largest delta on Earth, before disappearing into the Bay of Bengal. This cycle of flooding is violent, but it raises a question. What is left behind when the water finally recedes? As the floodwaters surge through the Tibetan canyon, they strip away millions of tons of glacial rock and soil, carrying this sediment down to the plains as fertile silt, or God. Once the weather changes, this thick deposit of silt provides the extreme fertility required for the agricultural bounty of Assam and Bangladesh. The Brahmaputra is a master geographic engine. The extreme climate shifts that cause its destructive floods are the exact same mechanisms that sustain millions of lives.